Hi everyone, welcome to lesson 5 of our trigonometry unit. Today's lesson is double angle identities. So for double angle identities, we have about 5 of them here, but the note here is for sine and for tangent double angle identities, we only have one option for each of them. For cosine, we have 3 different options. Which option is correct for cosine? Well, it depends on the question and what you need, so you're going to use whichever option you would need. This first option is basically just rewriting it in terms of a cos minus a sine, and that's only if you know both values there. The second option is if you only know cos, you might want to write your cos double angle in terms of all cosines. Down here, cos double angle, if you wanted to write it in terms of all sine, you'd use this last option. Right away, let's get into our first example here. So we have evaluate the following using a double angle identity. So if we have cos 120 degrees, let's rewrite that into a double angle. 120 degrees, of course, is the same thing as saying cos of 2 multiplied by 60 degrees. If I know it's 2 multiplied by 60 degrees, I can use any of those 3 middle options there for cos. I'm just going to use the first one. This is now saying cos squared of 60, because 60 is my angle, minus sine squared of 60. There we go. From here, we're just going to evaluate not with the exponents, but just evaluate the trig functions, and we'll deal with the exponent after. So I'm looking on my unit circle for cos 60. Cos 60 is just 1/2. That squared is going to be right on the outside still. Minusing off sine 60, and of course if I already had 1/2 here, this sine would have to be root 3 over 2, and the squared on the outside there. Evaluating both of these fractions with the squares, this is now on the left, we have 1/4 minus root 3 would cancel out because the square root and the squared would cancel, so we'd have 3 over 2 left over, or sorry, 3 over 4. 3 over 4, let's rewrite that. From here, we're just going to quickly evaluate, and we have negative 1/2 overall once you subtract those two fractions. So I can say cos of 120 is negative half, and if again you can verify looking on your unit circle, it is negative 1/2 there. You could have typed this in cos of 120 degrees on your calculator, and it also would have given you negative 0.5. In part B here, we have cosecant of pi over 3. So what can I do? I'm going to quickly rewrite cosecant. Cosecant is the same thing as saying 1 over sine pi over 3. Here I can rewrite pi over 3 as the same thing as saying 1 over sine multiplied, or 1 over sine of 2 multiplied by pi over 6. And again, if you're not too familiar with these, this is the same thing as saying 60 degrees. 60 degrees, 2 times 30 degrees, we get you back to 60 degrees. Here I have 1 over, and I'm going to start to fill in my equation. It's going to be 2 multiplied by sine pi over 6 cos pi over 6. Alright, there we go. And let's quickly evaluate this here. We have 1 divided by 2, that's just a number. Sine pi over 6, that's the same thing as saying 1/2. And cos pi over 6 is the same thing as saying root 3 over 2. If you multiply all this in, you're left with just root 3 over 2. So this is now 1 over root 3 over 2. If we evaluate this, this is now 2 over root 3, and of course we never want a radical in our denominator, so let's rationalize. So again, rationalizing is multiplying top and bottom by that radical. So we end up with an overall answer now of 2 root 3 all divided by 3. And there we go. That's going to be my exact answer for cosecant pi over 3. In example 2, we have write 2 sine 30 cos 30 as a single trig identity. Well, 2 sine 30 cos 30, this is the same thing as saying sine of 2 multiplied by 30. And of course, 2 times 30 there is just sine of 60 degrees. There we go. We have it as just one trig identity. In example number 3, we have if cos x equals negative 1 over 3, where x is, and here we are given a domain restriction. This is between pi over 2 and pi, so aka 90 degrees and 180. We want to find all three of these double identities. So let's first start by sketching out a quick picture to help us out. I know that pi over 2 is right at my 90 degree marker. Pi here is my 180 degree marker. If I have cos of negative 1 over 3, I'm going to draw a line somewhere in quadrant 2 there. Line straight down. Let's draw out our triangle. X is always going to be right here. X is our angle. Cos our adjacent and our hypotenuse side, so my adjacent side has to be negative 1. My hypotenuse side then would have to be 3. All I need is my opposite side, and you can find that using Pythagorean theorem. This is the same thing as saying root 8, because that's the same thing as saying 3 squared minus 1 squared, which is square root 8. From here, let's start off with all three. So sine 2x. So what does this look like? Sine 2x is the same thing as saying 2 sine x cos of x. Okay, x being the angle. From here, I'm gonna write down 2. 2 is just a number. Sine x, well, from this picture here, sine is opposite over hypotenuse, so it's going to be sine x is root 8 over 3. Cos x, negative 1 over 3. From here, let's clean this up and try our best to evaluate. Here you'd have negative 2 root 8 all divided by 9. But you don't want to leave this 8 here by itself. You can simplify that. This is the same thing as negative 2 square root of 4 times 2 under the radical now, because that's what 8 was, all divided by 9. Let's see if this helps. So we have negative 2 multiplied by another, not a negative, but that's just multiplied by another 2 with a root 2 there, all over 9. I'm just going to quickly clean this up. And this 2 came from the square root of 4, by the way. Here we have negative 4 root 2 over 9 overall. You can't simplify anything, so I just leave my answer as negative 4 root 2 over 9. In example B, we're looking at cos 2x. So again, I can use any of those three options earlier for cos. So I'm just going to use option 1 again. So I have cos squared x minus sine squared x. And here again, going back to our picture, cos is your adjacent over hypotenuse, so this is the same thing as saying negative 1 over 3 all squared, and that's going to be subtracted by root 8 over 3 all squared. From here we're going to try our best to evaluate. This first one here becomes 1 over 9. That negative goes away because it would have been negative 1 times negative 1. And over here this is going to be subtracted by 8 over 9 because our radical and squared would cancel out, and that 3 was squared. Here if we did our subtraction, this is now negative 7 over 9 overall. Last but not least, tan 2x, and we only have one option for tan 2x. This is the same thing as saying 2 tan x. All of that's divided by 1 minus tan squared x. There we go. And in this case here, let's start to rewrite everything. So we have 2 multiplied by, and of course tan is your Opposite over your adjacent, so that's going to be 2 multiplied root 8 over negative 1, that's 10. All of that's divided by 1 minus, again, tan here is root 8 over negative 1 all squared. And so let's quickly try to clean this up. Um, so here my numerator would end up being negative 2 root 8. That's my numerator. All of that's now being divided by denominator, which is 1. In this case here, if you square this, that's the squared would go away, that negative would go away, so it's going to be minus 8 overall. Scroll down a bit. So we have here negative 2 root 8 still up top in our numerator, in our denominator just negative 7. The only thing we can kind of clean up here is our double negatives and simplifying that radical. So here I have 2 over 7, and that radical now is the same thing as saying multiplied by 2 root 2. So we have an overall answer here of 4 root 2 over 7. There we go. In the next example, example 4, it says consider the expression sine 2x divided by cos 2x plus 1. What are the NPVs? What are the non-permissible values first? Well, we have a denominator here, and that's going to be where NPV is going to be found. So our NPV is, let's start off with cos 2x plus 1 cannot equal 0. From here, I want to get rid of this double angle. Let's rewrite it into something that we can work with. I'm going to rewrite it in terms of all coses, and here's why. If I rewrite this in terms of all coses, this is now 2 cos squared x minus 1. That was this rewritten. We still have that plus 1 cannot equal 0. The reason why I wanted that minus 1 there and use the second option is that minus 1, that plus 1 there will cancel each other out. So we're left with just 2 cos squared x cannot equal 0. Dividing both sides by 2, we have cos squared x cannot equal 0. And of course we're going to square root both sides, and that still really doesn't do anything. So we have cos x cannot equal 0 still. So what is x? X cannot equal, let's take a look at our unit circle. If we look at it, it's going to be at 90 degrees and at 270 degrees. That's what cos is equal to when cos is equal to 0. So I can say x cannot equal 90 degrees plus 180 degrees n, where n is an element of an integer, and that there will help us list off all our NPVs. If you had done this in terms of radian, you'd get the same answer. It's just you'd have x cannot equal pi over 2 and 3 pi over 2. And your restriction general statement would be x cannot equal pi over 2 plus pi n, where n is an element of an integer. Last but not least, it says simplify the expression to one of the three primary trig ratios. And again, just a quick reminder, your primary trig ratios I'm looking for are sine, cos, or tangent. And that's what you want to simplify this equation down to. So let's give that a shot. So what do we have? We have sine 2x, which I can rewrite immediately as 2 sine x cos x. That denominator, again, you could choose any option. I'm still going to continue to choose the same option. So we got 2 cos squared x minus 1 plus 1. And again, why that minus 1? I want to cancel out that plus 1. So this simplifies down to 2 sine x cos x all divided by 2 cos squared x. And here we can cancel out a few things. You can cancel 2 with 2. this cosine x with that squared because we'd have two coses, so then we're just left with this. So overall we have sine x left over in our numerator, cos x in our denominator. And there we go. This here, sine over cos, is the same thing as saying, and it says one of the three primary trig ratios, that's the same thing as saying tangent x. And that's our final answer. Verify your answer from part B in the interval between 0 and 2 pi using technology. So in this case here, it's asking us to verify using radians. So let's go to our graphing calculator right away. So I just loaded up my graphing calculator. Here's what I have. I'm going to type in y1, y2. y1 is going to be the original equation. y2 is going to be our tangent x. So I'm going to go tan x there for y2 right away. In y1 we want to type in the original, so the way I type it is use this fraction function here, because that's what we have. We have sine 2x, so that's the same thing as saying sine 2x in brackets there. Perfect. And in our denominator there it would have been cos 2x, and we had plus 1 after that. Don't forget to close bracket and then plus 1. What we're looking for are the same values, so second graph brings you up a table of values, and if you compare, yes, all our y values are the same across the board. Let's take a look at our Windows settings. So I'm going to change my Windows setting between 0, 2 pi, going up by, let's go up by something like a pi over 6. The lowest we really need to go, we can go as low as -2. Ooh, and I used -2 by mistake. -2 and 2, going up by 1 should be sufficient. And there we go. That's going to be our graph. That's y1, y2. Notice that they overlap, so they do check out these. This tan x, our simplified equation, does match up with the original. And again, two ways to look at it. You're either looking for your graphs to overlap, or you're looking for your table of values to have the exact same values. Okay. And there you have it. That's the end of our lesson. If you have any questions, please feel free to ask.